You know that slight pause you get sometimes before a chatbot replies? Well, that's not just the AI thinking. A lot of the time, it's the AI rereading. It's rereading everything you've said from the very beginning. And it's that little delay that kind of breaks the spell, right? It shatters the illusion of a real conversation. So today, we're going to dive into the absolutely brilliant engineering that's teaching AI to kick that habit and just, get to the point.
Okay, so let's kick things off with this analogy from an engineer named Timothy, because it just perfectly nails the problem. Imagine you're talking to a librarian. You ask them a question about the last chapter of a book, and to answer you, they have to start at page 1 and read the whole thing, all over again, every single time. It sounds absurd, but that's pretty much what a lot of AIs were doing, and it's just a massive, massive waste of time and energy.
And this isn't just, a minor inconvenience, it's a real, fundamental cost. So much so that the people who build these systems actually have a name for it.
It's called the rereading tax. And here's what it means. Every single time you add a new message, the AI has to go back and reprocess the entire conversation from the very start. This is the culprit behind that delay, what engineers call first token latency. It's that gap between your question and the very first word of the AI's answer. And believe me, that latency is a big deal. It's the difference between a chat that feels totally natural and one that feels, clunky and robotic. It's a tax you're paying in computer power, in time, and ultimately in the quality of the conversation itself. So how do you get rid of this tax? Simple. You give the AI a memory. And the goal here isn't just about making it faster, it's about something much deeper. It's about moving from a system that basically has amnesia to one that actively manages what it knows. One that creates a persistent context, making the AI feel less like a machine and more like a real partner in conversation.
So let's jump into the first part of the solution. This one tackles the most obvious, most predictable part of the problem.
The first question you gotta ask is, what about the stuff that never changes? The initial instructions, the system prompts that tells the AI, hey, you're a helpful assistant, or you need to talk like a pirate. Why on earth would you reread that every single time? The answer is so elegant. You don't reread it. You lock that initial thought away and just reuse it. This super simple but incredibly powerful technique is called prefix caching.
Now, what's really cool about this is how simple and powerful it is. The AI does the math for those fixed instructions, like the system prompt, just one time. Then it locks that result away in a super fast memory cache. It's basically like our librarian has finally memorized the first few chapters of the book. And here's the best part. If thousands or even millions of people are using the same AI assistant, they can all share that one cache result. It completely changes the game, turning a slow read into an instant recall.
Okay, that's great for the static part. That handles the intro to the book. But what about the story itself? What about the actual conversation, which is changing and growing with every single reply? And this is the next major hurdle, right? You can't just cache the whole conversation, because it's completely unique for every single person. It's a moving target, so you need a way more dynamic approach.
So instead of having our librarian reread the entire book over and over, we need them to build a kind of mental map of the conversation as it's happening. And that brings us to the real heart of modern AI memory, something called KV caching.
So here's the absolute crucial point. We are not saving the raw text of the conversation. Instead, as the AI processes what you say, it generates these things called keys and values. For every single word, it creates a key that basically asks, what am I? And a value that answers, here's what's important about me in this context. You can think of them like the mathematical fingerprints of the conversation. So when it's time to generate the next word, it doesn't have to reread all the previous sentences. It just looks at its map of all these fingerprints. It's following a mental map, not rereading the book.
All right, so we've given the AI a memory, which is awesome. But now we have a totally new problem. What happens when that memory gets too big?
Exactly. A really long, in-depth conversation can create a huge cache of these mathematical fingerprints. And if you're not careful, you'll either run out of memory completely, or it'll become so messy and fragmented that everything slows down and you're right back where you started. So the solution here isn't to just find a bigger room for the library, is to be smarter about how you organize the shelves. This idea actually comes from a classic concept in computer science, perfectly adapted for the world of AI, paged memory management. And this is just a brilliant way to handle a ton of information. Instead of trying to reserve one giant, continuous block of memory for the entire conversation, which is incredibly wasteful, the system breaks the memory down into small, fixed-size chunks called pages. It only grabs the pages it needs right when it needs them.
It's like our master librarian organizing the archive not as one giant, messy room, but as a series of small, perfectly organized shelves, only using them when necessary.
So what happens when you put all of these pieces together? You get prefix caching, KV caching, and this paged memory management all working in harmony. Well, you get a system that just feels completely different.
You get a system where this little light, the cache hit indicator, is just flickering on constantly. And that's a beautiful sight for an engineer, because it means the AI is almost never rereading from scratch. It's constantly pulling from its memory, from its cache. It's recalling information instead of reprocessing it.
And for you, the user, the result is basically magic. The responses feel instantaneous. The conversation just flows, without any of those awkward, jarring pauses. The AI feels like it actually has a short-term memory, like it's right there on the same page with you. Because thanks to this amazing architecture, it literally is.
So, let's do a quick recap of everything we just covered. We started with the big problem, the rereading tax, which is the source of all that slowness. We solved the static, unchanging part with prefix caching. Then we handled the dynamic part of the conversation with KV caching. And finally, we solved the memory overflow problem with paged memory management. See how each piece builds on the last? It all comes together to create a system that's truly efficient and truly conversational.
And this quote from Margaret, the memory architect, is the perfect way to wrap this all up. Building a truly intelligent AI isn't just about raw speed or brute force. It's about being smart. It's about designing a system with a memory, an architecture so elegant and efficient that it never ever has to waste a single moment reading the same thing twice.